Right, people, last lesson before the final exam. That's pretty exciting. So we're doing scientific notation in real world situations. And I found that lesson actually really interesting, that he talked about the stimulus checks and how much that's actually costing. And I liked it. So a comet is estimated to be about 960 million kilometers from Earth. Write the distance in scientific notation. So we're going to keep the digits of value. We're going to go 9.6 times 10. How many places do we have to move the decimal from 9.6 to get this? So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power of 8. The star is estimated to be, this is hundreds, thousands, millions, billions, trillions. So 150 trillion kilometers away from Earth. Write this distance in scientific notation. So we go 1.5 times 10 to the power of 3, 6, 9, 12, 13, 14. Alpha Centauri is estimated to be about 41 trillion kilometers from Earth. Write the distance in scientific notation. 4.1 times 3, 6, 9, 12, 13. Okay. In the science fiction movie, a spaceship can travel 2.4 times 10 to the power of 5 kilometers per second. It is traveling to a planet that's 8.7 times 10 to the power of 14 kilometers away. How long in seconds must a spaceship travel to get there? Well, we have to do this problem. 8.7 times 10 to the power of 14 divided by 2.4 times 10 to the power of 5. So let's go ahead and write the numerator and the denominator out in standard form, and then do the division and then convert it back into scientific notation. So 8.7 times 10 to the power of 14. So 8, 7. That's one digit. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So just a few zeros. That's just like, a little number there. 2.4 times 10 to the power of 5. So 2, one digit, 2, 3, 4, 5. Okay. We can cross off the zeros that match at the end. We want to simplify it a little bit. Oh, how many is that? 3, 4. So what we can put on our calculator is 1, 2, 3, comma 8 billion 700 million divided by 24. But what I want to do is I want to see if I can just put this whole thing in the calculator and see if it gives me the right answer. So we'll do it this way first. 8 billion 700 million divided by 24. 8 billion 700 divided by 24 gives me 1, 2, 3, 1, 2, 3, 362,500,000. 362,500,000. Or written in scientific notation, this would be 3.625 times how many places after the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 10 to the power of 8. So that's what we get. But let's see if we can, like I said, try to put the whole thing in the calculator and see what it does. 8.7 times 10 to the power of 14. Put it in parentheses. 8.7 times 10 to the power of 14 divided by 2.4 times 10 to the power of 5. 2.4 times 10 to the power of 5. And I get 3,625,000,000. Is that what I got last time? Not quite. 1, 2, 3, 4, 5, 6. So I almost got it, but it should be to the power of 9. Somewhere along the lines I made an error. I'm assuming it is somewhere in this zeros mess. So what that showed us is that you can put this in the calculator, and then all you have to do after doing that is convert it back into scientific notation. So let's do that. Starting from here, our digits of value are 3, 6, 2, and 5. So I'm going to write 3.625. Times 10 to the power of, we are going to count how many places we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. To the power of 9. Okay, let's do this one in the calculator again. 9.6 times 10 to the power of 7. So I don't have to write 100 million zeros. 9.6 times 10 to the power of 7. Put it in parentheses. Divided by 3 times 10.5. 10 to the power of 5. Bye-bye. Okay, we get 320. So we'll keep the digits of value. We'll write 3.2. Times 10 to the power of, to go from 3.2 to 320, we would move the decimal twice. The star Polaris is estimated to be hundreds, thousands, millions, billions, trillions, 4 quadrillion, 100 trillion kilometers from Earth. Write this distance in scientific notation. Okay, so our digits of value, 4.1. And then we count after the decimal that we just put. So right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, Earth's mass is about 5.7 times 10 to the power of 24 kilograms. Venus's mass is about 4.87 times 10 to the power of 24 kilograms. What's the difference between the mass of Earth and the mass of Venus? What they've done, which is nice, is they've given us the same power in both of them. So if you remember, if we are adding or subtracting in scientific notation, the only time that we can just add or subtract the numbers, like the 5.97 and the 4.87, is when we have the same powers. So we're just going to do the subtraction. So we have 5.97 minus 4.87. So if you do that in a calculator, you're going to get 1.1 times 10 to the power of 24. And we're on to the final review. Good luck.